Hi, everybody. So, yes, I'm Karen Jex. I'm a Senior Solutions Architect at Crunchy Data. Job title doesn't really tell you very much, but hopefully it'll become clear. And I'm here to tell you how to keep your database happy. The right button will help, won't it? Okay, so first of all, I have to get the confession out of the way. I'm not a developer. I'm sorry. But as you can see from this illustration of my career so far, I do know about databases, having worked with them exclusively for the last 25 years. In fact, my current job title is the only one that hasn't had database in it, but I still work exclusively with databases. I've learned a lot from the developers that I've worked with along the way, and I've tried, as I've gone along, to teach them and share with them what I know about databases. So that's what I'm trying to do today. So I'm here to talk about databases and about Postgres in particular. And one of the things that Python developers and other developers tell us they like about Postgres is that it just works, which is great because it means that you can focus on what you want to do and what you need to do, and you don't have to spend too much time looking after your database. So in the abstract, I promised you my top 5 tips of things that you can put in place fairly easily to make sure that you've got a robust, performant database environment. So here we go. Number 1, make sure that a few key configuration parameters are set correctly for your environment and workload. Tip number 2, make sure you take regular backups of your database and test your recovery process. Tip number 3, put a high availability architecture in place. Tip number 4, make sure that the right users and applications can connect to your database and interact with it. And finally, tip number 5, make sure you know what's going on in your database and you can react quickly if anything goes wrong. So there you go. Thank you very much. Okay, so we've got probably 3 minutes to go through each of those in detail. Tip number 1, check the settings of a few key configuration parameters. So out of the box, the Postgres cluster has a really small footprint, which is fantastic because it means that you can install Postgres pretty much anywhere without having to worry about resources. But those default parameters that it uses might not be right for your production environment. There are actually 361 parameters that you can set in Postgres 16, but fortunately you don't need to look at all of those. Setting a few of those can be enough. So, for example, you want to make sure you've got the right amount of memory allocated to your database, and you want to configure your wall and checkpoints. You don't want too many checkpoints, you don't want too few, you want just the right number. So some of the parameters that you might want to set. Shared buffers is memory allocation. It's allocated at Postgres startup. That's dedicated to Postgres for caching data. The default value for shared buffers is 128 meg. As long as you've got more than about 1 gigabyte of RAM available on your system, you want to look at setting that to probably 25 to 40% of RAM. Everything I say here really is a rule of thumb. It's going to be a case of, try things out, see what works. Workmem. Workmem's an amount of memory available to a query operation for things like sorts and hash operations before it then spills to disk and creates a temporary file. The default there is 4 megabytes. Queries that perform large sort or hash operations will probably benefit from a higher amount, possibly a much higher amount. You might want to just pluck a number out of thin air and say, let's set it to 10 megabytes, but just be aware that it's per query operation. A single query could actually perform multiple operations and therefore use many times workmem. So if it's set too high across the board, it could use a massive amount of memory. So you probably want to look at specific sessions that actually need that increased memory and just set it for those. You can use the log temp files parameter, which will then show you in your Postgres logs if temporary files are being created. If you see lots of temp files being created, that will indicate that you need to increase workmem, at least for certain sessions. Maintenance workmem, so a similar idea, but this time for maintenance operations like vacuum, create index, or alter table, add foreign key. This one's set to 64 meg by default. You're unlikely to have a lot of concurrent maintenance operations, so actually you can afford to set this one much higher. And a good starting point there is consider about 5% of your RAM. So looking at these all together, the main thing to bear in mind is that obviously the total for all this memory shouldn't exceed what you have available. Wall and checkpoint tuning. So during a checkpoint, Postgres will flush all of your dirty data pages to disk. They're already persistent because they've already been written to your wall files. But checkpoints are expensive. They're expensive I/O-intensive operations, so you don't want them to be happening too often. On the other hand, if you leave too long between checkpoints, then your crash recovery could take a long time, and you also need space available on disk to store the wall files between those checkpoints. So to tune that, you can look at wall buffers. So wall buffers is the amount of space that Postgres has available for the wall before it's synced to disk. It will also be synced to disk at every commit. So this one is useful to increase if you have a lot of concurrent connections. The default of -1 actually means that Postgres will calculate it automatically. It's about 3% of shared buffers, or up to the equivalent of one wall file, which is 16 meg by default. So you could try something like 32 megabytes for that if you've got multiple concurrent connections. Checkpoint timeout. So if a checkpoint hasn't taken place in the last checkpoint timeout seconds, then a new checkpoint will be triggered. The default for this is 5 minutes. What you want is for your checkpoints to be triggered by a timeout so you've got predictable behavior. Most people think that 5 minutes is too low, so we'll set it to somewhere between 10 and 30 minutes. Max wall size is another way that a checkpoint can be triggered. So if this amount of wall has been generated since the last checkpoint was triggered, we'll get a new checkpoint. So this can help make sure that you don't run out of space in your wall directory if you've got a sudden, unexpected, large amount of change in your database that's generating a lot of wall. So it's kind of a backstop. So the default value of 1 gigabyte here is equivalent to 64 16 megabyte wall files. The Postgres documentation says, set this to half to 2/3 of the space that you have available for wall. Fantastic, thank you. How much space do I need for my wall? The ideal here is to just keep an eye on your log file. Your Postgres logs by default will log checkpoints. You can see when and why they're being triggered. If you're frequently having checkpoints triggered by max wall size, then you probably want to have that higher and make sure you've got enough space in your wall directory to cope with that. Okay, how are we doing time-wise? Well, we're going to have to speed up a little bit. Tip number 2, backups. I'm going to make the assumption that the data in your database is somewhat important to you and that if something goes wrong with it, so we even have explosions, if something goes wrong with it, you want to be able to recover it. And for that, you probably want to take backups. So what do you need? You need somewhere to store your backups, which is usually called a backup repository. This can just be a directory on your database server, but preferably it'll be on a different server, in a different data center. It could be network storage, cloud storage. You just need somewhere to store those backups. You need a backup tool, such as PG Backrest or Barman. Both of these are community-maintained tools. And you need some means of scheduling your backups. You probably need online backups, i.e. you can't take your database down whilst you take backups. And you probably want point-in-time recovery, which means you want to be able to recover to any given time in between 2 backups. So for that, you need to put wall archiving in place. Wall archiving is just saving your wall files to a separate location, in this case, your backup repository. So you'll switch archive mode on, And you'll set an archive command, and the simplest form of that is simply a CP to copy your files to somewhere else. And then you need to use a tool such as PGBackrest to take regular backups of your database. So a backup is a copy of your data files plus the wall that's generated during the backup to make sure that when you restore, you can get back to a consistent state of your database. So to prove this one's quick and easy, I've said I'll go through a super fast, minimal setup of PGBackrest. I will really zoom through this, but I've given the link here to the quick start guide in PGBackrest, so you can go back to it and have a look how to do that, and I will make sure I share the slides. So install PGBackrest. Create or edit a PGBackrest conf file, so you can include just real minimal information in here. You've got a global section which tells it where your backup repository is, so where it should store those backups. I've included a retention period so that old backups are expired and you don't have to worry about filling that backup repository. And I've done a main stanza, as they call it, which you can call whatever you like. That's for my database cluster, which is called main, and that's just to tell it where the data directory is, so where is that database. Once you've done that, you need to change your archive command so that it's now using PGBackrest's archive push, so that will push all of your WAL files off to your backup repository. Restart Postgres once you've done that. And then you issue a couple of PGBackrest commands to initialize your stanza and check to make sure everything's running. And that will actually archive a WAL to make sure that everything's in place. And then you can just use the PGBackrest backup command to take your backups. If you miss the type equals full out of here, by default, it will do an incremental backup for you. And then whatever method you want to schedule your backup. So here I've just created two simple cron jobs. I've got one to do a weekly full backup and one to do a daily differential backup. And there's the info command that you can use to get details of the backups that are in your repository. And you've probably all heard already of Schrödinger's backup. The condition of any backup is unknown until a restore is attempted. Not only that, if you do have to restore, it's going to be an emergency. There'll be users and managers breathing down your neck. It'll be the middle of the night. And the person that wrote the backup and restore procedures probably left the company a year ago. So test and practice your restore procedures. You want to be sure that you know how to do it and that it will work. Tip number 3, put a high availability architecture in place. It's fantastic to know you can recreate your database from a backup if something goes wrong, but your users might not be willing to wait for that to happen. Most production environments need some kind of high availability. And obviously this one, as you can imagine, isn't as quick and easy to put in place as some of the other options. If you don't have the time, the skills, the inclination, or the infrastructure to do that, there are various managed Postgres services available that will do this for you. So, step by step, assuming you've already got a standalone database up and running, you can use Postgres's physical streaming replication to push your changes to one or more replica or standby databases. There are then various tools or frameworks that you can use that will monitor your cluster, and if something goes wrong, another explosion, with your primary database, it will then make sure that a primary takes over a standby takes over as the new primary. In this case, so the architecture that we use is with Patroni. Patroni needs a DCS such as etcd that your database servers can talk to without too much latency to store the current state of each of those servers. Setting it up, you kind of just install Patroni, make a couple of changes in the configuration parameters, tell it where to find etcd, and it kind of automatically manages your cluster for you. Funnily enough, there is a little bit of pesky detail in each of those steps. And we don't have time for a full database high availability workshop, which would probably take about a day instead of 3 minutes. So what I've done is just put the links there to the documentation for Postgres, for etcd, and for Patroni, so that if you're interested in setting that up for yourself, I mean, it's quite a good fun exercise to do. If you're interested in setting that up for yourself, you can go and look at that documentation. Please don't try this for the first time in a production environment. I hopefully won't get sued for any recommendations I make otherwise. Okay, tip number 4, configure connections. You want to make sure that the right users and applications can connect to and interact with your database. I'm making the assumption here that you want at least some people to be able to connect to your database. But you want to control where those connections come from, and you want to control how they're authenticated. You don't want too many concurrent connections because you don't want to be using too much resource. And you don't want inactive sessions to be blocking other users. You need to make sure that you create appropriate application users. So you need application users that have just the right level of privilege to do the tasks that they want to do in the database. Hopefully it goes without saying, but you don't want your applications or anybody really to be connecting to the database as the Postgres super user. That's very much a do as I say, not as I do. In any of my examples, you'll see I always connect as Postgres. So some of the parameters that you can use to manage connections. Listen addresses specifies which host names or IP addresses Postgres will listen to. It's set to localhost by default, which means that Postgres will only listen for local loopback connections. Assuming that you want to allow external connections, you can either set it to a list of IP addresses, or you can set it to asterisk if you want to allow connections from all available IP interfaces. Max connections, the maximum number of concurrent connections that are allowed to your database. The default's 100 on most systems. The temptation might be to set this really high so that you never get any connection errors. Please don't do that. Postgres generally works best with up to a few hundred concurrent connections, and on a small system, maybe even less than 100 connections. If you want many hundreds or thousands of connections, then you need to start looking at connection pooling. And that's a subject for another talk. This one I quite like. I've had multiple occasions as a DBA where somebody has started a transaction, they've run a few queries, and then they've locked their computer, they've gone off for lunch, they've gone home for the evening, or they've even gone off on holiday, and their transaction is still there. It's still holding all of the locks that it took, and it's blocking other users and stopping vacuum from being able to clear dead rows in the database. Idling transaction session timeout will terminate any session that's been sitting with an open transaction but not doing anything for more than that amount of time. It's disabled by default. If you set that to, say, 30 minutes, then it will terminate sessions. So if Carrie opens some transaction, runs some queries, goes off on holiday, it will terminate that session, but it won't impact, say, Fred, who's just gone and got distracted by the coffee machine for a few minutes. And then you control your client authentication by creating entries in the pghba.conf file, Postgres host-based authentication file. It's kind of a firewall-ish. So each record in the pghba.conf says which database user is or isn't allowed to connect to the database, the range of IP addresses that they're allowed to connect from, and which authentication method can be used. There's a default pghba.conf, but that by default only allows local connections. It can be a bit complicated to figure out exactly which entries you want in there. You can just use stars across the board and let anyone connect from anywhere. Probably not the best idea. So I've, again, put a link to the documentation, which has got really useful, actually, explanations and examples of different entries that you can use there. I think we're good. We're on the final tip. Okay, so tip number 5. Make sure that you know what's going on in your database so that you can react quickly if something goes wrong. So once you've put all those things in place, things should just tick along nicely. But if something does go wrong, you want to know about it and you want to do something about it. You might want or need to put in place a fancy monitoring system with Grafana dashboards and alerts that tell the right people if a threshold's exceeded or if a certain action happens. But even without those things, the Postgres logs can be a really valuable source of information. So first of all, you want to make sure that logging collector is set to on so that your log messages are being collected and sent to your log files. If it's not, you'll need to just change this parameter and restart Postgres. Then you want to make sure you can find your logs. So, show log directory. My logs are in a directory called log. Yay! Where is that? If it's not an absolute path, it's relative to the data directory. So if you do a show data directory, you can see where that is. This is the, I'm just proving that I am up to date and I've created a Postgres 16 database. And then log file name will show you how those files are named or allow you to rename them yourself if you prefer something other than the default. There are some parameters that you can set to make sure that you've got useful information in your logs. So log min duration statement can help you to identify unoptimized queries. It's disabled by default, but if you set it to 1 second, for example, it will log all completed queries that took at least 1 second. The actual value will depend on what's normal in your system, because you probably only want to see outliers rather than most queries because you don't want lots of noise in your logs. Logline prefix, that's a string that's added to the beginning of each line in your log file. And the default is timestamp and process ID, which doesn't necessarily help you with debugging because it doesn't tell you much about what was doing a particular operation that made it into the logs. So I've given an example here. You can use all sorts of different flags and any text you want. So just as an example, I've added in timestamp, the host that's being connected from, the database user that's connecting, the database that they're connecting to, and the process ID. And then for me, one of the most important bits, and now I can't quite get my pointer working, is the space at the end, just to make it legible and so that you actually separate it from your message. pgstat statements is a really useful tool for checking what's going on in your database. It's an extension, 2 simple steps to configure that, add it to your shared preload libraries and restart Postgres. And then in any database where you want to use it, do the create extension pgstat statements. You can then query the pgstat statements view to get information about long-running queries or frequently executed queries. Again, link to the documentation so that you can go away and look at more information about that. And then I think I am just in perfect time to go to the conclusions. So Postgres really does just work, and you shouldn't have to do too much to it. But to make sure your database is happy, check a few key configuration parameters, make sure they're right for your database. Take regular backups of your database and test your recovery. Put a high availability architecture in place, or consider using a managed Postgres service that will do that for you. Make sure that the right users and applications can interact with your database. Make sure you know what's going on and you can react if something goes wrong. And then you can leave your database to look after itself. Thank you very much.
We have actually got a few seconds left, so there is time for one question, if anybody has one.
Hi.
For managed databases,
Yes.
can I assume that they're configured in this nice way?
It will very much depend on the vendor.
Well, that was the one question. Thank you very much, Karen. And a round of applause for Karen.
Thank you.